Chapter 10: When Resolution Fails. Resolution failure is what turns inflammation from a useful biological program into a chronic operating condition. The body still detects disruption, still initiates defense, still recruits inflammatory cells, still changes vascular tone, still amplifies pain sensitivity, and still mobilizes lipid-derived signaling. In that sense, much of the machinery remains functional. What breaks is the transition. The tissue does not move cleanly from force into cleanup, from cleanup into repair, and from repair into restored control. Instead, it remains suspended in an unfinished middle. Recruitment slows, but does not truly stop. Debris accumulates faster than it is cleared. Macrophages are present, but do not finish effectively enough to empty the site of inflammatory residue. Vascular permeability remains too open. Barrier surfaces remain too compromised. Membranes remain structurally unstable and continue releasing the biochemical evidence of damage. The result is not simply inflammation that lasts too long. It is inflammation that has lost its end state. This is one of the most important distinctions in modern chronic disease. The body is often not failing because it cannot produce inflammation. In many cases, it produces inflammation very well. It can still generate eicosanoids, cytokines, adhesion signals, oxidative chemistry, and acute immune traffic. The deeper failure is that this early and middle phase chemistry is no longer being brought under the command of a competent resolution program. Specialized pro-resolving mediator production may be insufficient relative to the burden of initiation. Omega-3 derived substrate may be too limited, too poorly incorporated, too oxidatively vulnerable, or too weakly converted downstream into useful pro-resolving signals. Macrophage cleanup may be incomplete. Barrier damage may continue feeding fresh triggers into the system. Mitochondrial stress may limit the energy required for actual tissue repair. In that setting, the body keeps reopening a process it never truly finished the last time. When resolution fails, one of the first things that happens is that inflammatory evidence stops disappearing. Apoptotic neutrophils are not removed efficiently enough and begin to break down into secondary inflammatory material. Oxidized lipids remain in tissue. Damaged membrane fragments remain visible to immune surveillance. Protein debris and extracellular matrix damage continue distorting the local environment. What should have become quiet removal becomes persistent provocation. The tissue stays chemically legible as a site of active disruption, even if the original trigger has diminished. This is why chronic inflammation often feels disproportionate to the current insult. The body is not always responding only to what is happening now. It is often responding to what was never successfully cleared from what happened before. This unfinished state also changes the behavior of immune cells themselves. Neutrophils may continue to arrive because the site continues broadcasting signals of unresolved damage. Macrophages may remain trapped in inflammatory or mixed phenotypes rather than fully transitioning into high-efficiency cleanup and repair support roles. Cytokine signaling remains elevated not because the body has chosen meaningless excess, but because the tissue continues to present conditions that justify continued surveillance. A site that has not been cleared cannot persuade the immune system to stand down. The immune system is responding to the fact that the site still looks unfinished. Resolution failure therefore becomes self-reinforcing. The longer the tissue remains unresolved, the more inflammatory logic it continues to justify. Barrier dysfunction is often central to this process. A tissue cannot resolve while fresh triggers keep entering the site faster than the system can process the previous ones. In the intestine, this may mean microbial products, incompletely contained luminal contents, or recurring epithelial injury continue feeding immune activation. In vascular and tissue barriers, excessive permeability may keep immune traffic and signaling molecules moving into places that are supposed to be closing back down. At the cellular level, oxidatively damaged membranes may continue releasing danger-associated chemistry that makes surrounding cells interpret the environment as unstable. Resolution requires decreasing provocation. If provocation stays constant, the body never receives convincing evidence that the emergency phase can safely end. Energetic failure compounds this problem. Repair is expensive. Cleanup is expensive. Membrane reconstruction, junctional restoration, re-establishing gradients, recycling damaged components, and shifting immune cell behavior all require organized ADP production. A metabolically strained tissue may still initiate inflammation because initiation can run on stress signaling, stored substrate release, and acute defensive logic. but it may fail during the labor-intensive phase of closure. This creates one of the defining patterns of chronic illness. The body has enough force to begin, but not enough integrated energy to finish. Symptoms persist not only because the wrong signals remain active, but because the tissue lacks the energetic margin to execute the work those signals are supposed to direct. This is also why chronic pain, chronic swelling, chronic fatigue, chronic vascular irritation, and chronic immune activation so often travel together. They are different expressions of the same unresolved tissue state. Pain persists because nociceptive amplification has not been withdrawn from a site still broadcasting damage. Swelling persists because vascular and barrier control have not normalized. Fatigue persists because the body remains metabolically committed to defense and cleanup it has not completed. Immune activation persists because the tissue keeps presenting evidence that the job is unfinished. The person experiences separate symptoms. The underlying failure is often one thing. The body has not successfully converted an inflammatory event into a resolved tissue environment. Resolution failure also reframes the meaning of treatment failure. If one only thinks in anti-inflammatory terms, then partial symptom reduction may look like adequate progress. But a quieter tissue is not necessarily a resolved tissue. A suppressed site can still be full of uncleared debris, unstable membranes, dysfunctional macrophage behavior, unresolved barrier damage, and ongoing retriggering. This is why symptoms so often return. The sequence was muted, not completed. The body was not helped into resolution strongly enough to stay there. A true resolution-centered view asks different questions. Has recruitment stopped because the site no longer needs it, or only because a signal was blocked? Has debris actually been removed? Have barrier and vascular controls recovered? Has tissue stopped generating evidence of active danger? Has immune behavior shifted from persistence into completion? Without those transitions, the inflammatory program remains unfinished even when it is less loud. This chapter matters because it changes the entire emotional and biological meaning of chronic inflammation. The body is not necessarily broken in the sense of losing all defensive intelligence. Often it is defensively overcommit because it cannot obtain the evidence required to exit. It keeps acting inflamed because unresolved tissue keeps telling it to do so. That means the path forward is not merely reducing inflammatory intensity. It is rebuilding the conditions under which inflammation can end. That includes restoring membrane composition, improving omega-3, derived resolution substrate availability, improving downstream conversion into specialized pro-resolving mediators, strengthening macrophage cleanup, restoring barrier function, lowering repeated triggers, and supporting mitochondrial capacity for repair. Resolution failure is what makes chronic disease chronic. It is the point where the body stops suffering from an event and starts suffering from its inability to complete that event well. SPM deficiency. SPM deficiency does not mean the body is incapable of producing inflammation. It means the body lacks enough of the specialized pro-resolving mediator signal environment required to bring inflammation to a proper end. That distinction matters because many chronically inflamed tissues are not weak in initiation. They are often highly competent at initiation. They can release arachidonic acid, generate eicosanoids, recruit neutrophils, alter vascular permeability, amplify pain, and sustain immune traffic. What they lack is sufficient downstream pressure toward closure. In that setting, the tissue remains rich in go signals and poor in stop signals. It is built to escalate more easily than it is built to complete. SPM deficiency therefore describes a state in which the later phase biochemical intelligence of inflammation is underpowered relative to the force of the earlier phases. This deficiency can emerge from several levels at once. The first is inadequate precursor availability. If EPA and DHA are not sufficiently incorporated into membrane phospholipids, the tissue simply does not carry enough raw material from which resolvins, protectins, and marazins can later be generated. The second is poor downstream conversion. A person may have some omega-3 in circulation or tissue, yet still fail to derive meaningful pro-resolving output if enzymatic routing, tissue state, or inflammatory timing remain biased toward initiation-heavy pathways. The third is excessive oxidative instability. EPA and DHA are highly unsaturated, which makes them biologically useful but also chemically fragile. If membranes are heavily oxidized, if antioxidant protection is poor, or if inflammatory damage is repeatedly injuring the same tissue, omega-3 derived substrate may be degraded or functionally underexpressed before it can support a strong resolution program. The fourth is chronic retriggering. Even where some SBM generation exists, repeated barrier leakage, persistent endotoxin exposure, ongoing tissue injury, or mitochondrial distress may keep the inflammatory site under such constant activation pressure that the pro-resolving signal never gains dominance. The consequences of SBM deficiency are predictable once the sequence is understood. Neutrophil recruitment may begin normally but fail to shut down cleanly. Macrophages may arrive but remain less effective at efferocytosis and debris clearance. Apoptotic cells may accumulate and progress into secondary necrosis, turning what should have been quiet removal into fresh inflammatory provocation. Vascular permeability may stay elevated longer than needed. Nociceptive amplification may remain active after its protective usefulness has ended. Tissue barriers may stay compromised because the local environment never fully exits emergency mode. In this sense, SBM deficiency does not create a lack of inflammatory activity. It creates an excess of unfinished inflammatory activity. The body continues behaving as though more force is still needed because it has not been given enough later phase instruction to shift decisively toward cleanup and restoration. This is one reason chronic disease can look paradoxical. A person may have high inflammatory markers, persistent pain, slow recovery, and exaggerated immune reactivity, yet the deeper defect is not simply too much inflammation. It is too little resolution pressure relative to the amount of inflammation being initiated. That imbalance leaves the tissue stuck in a loop. Every inflammatory event creates debris and structural disturbance. Inadequate SBM action means that debris is not cleared efficiently enough. The uncleared debris then becomes part of the reason the next inflammatory event is triggered. The site never becomes convincingly safe enough for the immune system to stand down. SBM deficiency therefore turns inflammation into recurrence. The body keeps re-entering a process it never fully completed the last time. Seeing clearly SBM deficiency is one of the most useful ways to describe chronic inflammatory biology without collapsing back into vague anti-inflammatory thinking. It points to a missing phase, not merely an excessive volume. It says the tissue is poor at biochemical closure. It says the body still has the machinery of defense, but insufficient mediator strength to redirect that machinery into efficient efferocytosis, tissue protection, barrier restoration, and return to baseline. That is why the solution cannot be reduced to blunting early-phase inflammation alone. The deeper task is to restore the conditions under which SBM biology can become strong enough to matter. Adequate EPA and DHA incorporation, enough structural protection for those substrates, competent downstream conversion, reduced retriggering, effective macrophage cleanup, and enough metabolic capacity for repair. Only then does the body regain more than symptom relief. It regains its missing half of inflammatory intelligence. Enzymatic bottlenecks, COX/LOX pathways. Enzymatic bottlenecks in the COX and LOX pathways help explain why the presence of omega-3 substrate does not automatically guarantee strong pro-resolving output. EPA and DHA may be present in membranes, but they still have to move through enzyme systems that are shared, competitive, context-dependent, and often already heavily occupied by arachidonic acid-rich initiation chemistry. Cyclooxygenase and lipoxygenase pathways do not operate in an empty space waiting patiently for omega-3 to arrive. They are already embedded inside inflammatory tissue states shaped by receptor activation, cytokine tone, oxidative stress, membrane composition, and the relative abundance of competing substrates. This means the body can carry the raw material for resolution and still fail to express that material efficiently if the conversion machinery remains bottlenecked at the level of enzyme access, enzyme preference, or phase timing. The first problem is simple competition. COX and LOX enzymes can act on multiple polyunsaturated fatty acid substrates, but they do not do so under neutral conditions. In a tissue heavily enriched with arachidonic acid, especially one that is repeatedly mobilizing omega-6 derived substrate during chronic inflammatory activation, the enzymatic traffic is already biased toward early-phase eicosanoid production. Arachidonic acid is being liberated, converted, and fed into pathways that sustain vascular change, leukocyte recruitment, pain sensitization, and inflammatory amplification. EPA entering that same environment is not automatically granted equal downstream influence. It is competing for shared enzymatic handling inside a site whose biochemistry may still be organized around initiation. DHA faces a related problem, especially when the tissue has not shifted far enough into the later phase for protectin-, myrisin-, and D-series resolvin-generating pathways to become meaningfully dominant. The precursor may be present, but the pathway remains crowded. The second problem is that enzyme activity changes with inflammatory phase. COX and LOX pathways are not simply on or off. Their behavior is shaped by the kind of tissue event underway. Early in inflammation, the system is built to generate force quickly. That means enzyme activity tends to favor mediator output associated with initiation and amplification. Later, if the sequence is functioning properly, the tissue undergoes what is often described as mediator class switching. The same broad enzymatic landscape begins favoring the production of lipoxins and omega-3 derived pro-resolving mediators rather than remaining locked in early-phase eicosanoid dominance. But if that switch does not occur efficiently, then the bottleneck is not only substrate competition, is a failure of phase transition. The tissue keeps using its enzymes as if it were still trying to build the front half of inflammation, even when what it actually needs is the back half. Oxidative stress can worsen this bottleneck by distorting the enzymatic environment itself. A chronically inflamed tissue is not just crowded with competing fatty acids. It is often redox disturbed, structurally unstable, and repeatedly injured. That environment can alter membrane integrity, enzyme localization, receptor signaling, and the broader organization of the mediator system. Even if omega-3 derived substrate is present, the tissue may remain too chemically disordered a route that substrate efficiently into coherent, pro-resolving output. Instead of a clean conversion sequence, the organism experiences partial incorporation, partial conversion, and persistent dominance of early-phase chemistry. This is one reason some people can increase omega-3 intake without immediately obtaining the resolution-oriented benefits expected from a simple nutrient model. The bottleneck is not only at the level of what enters the body. It is at the level of what the inflamed tissue can actually do with what entered. There is also a spatial dimension to this problem. COX and LOX pathway activity is not occurring in abstraction. It is occurring in membranes in specific cell types, under specific receptor conditions, and within tissues that have different demands and different substrate pools. A macrophage entering a proper resolution phenotype will not use the same enzymatic landscape in the same way as a neutrophil-heavy inflammatory site still dominated by acute recruitment logic. An endothelial surface under ongoing irritation will not necessarily convert substrate in the same pattern as a tissue beginning true repair. This means bottlenecks are not just global biochemical shortages. They are local failures of access, timing, and phenotype. The right substrate has to be in the right cell, in the right membrane pool, at the right phase, with the right enzyme activity surrounding it. Otherwise, resolution remains theoretically possible, but biologically weak. This helps explain why chronic inflammation often reflects not just too much arachidonic acid-derived signaling, but too little successful enzymatic rerouting toward pro-resolving mediator generation. The tissue keeps producing what it already knows how to produce. It keeps entering familiar eicosanoid cascades because those pathways are well supported by both substrate abundance and inflammatory context. Meanwhile, the omega-3 derived side of the system remains underexpressed, not necessarily because EPA and DHA are absent in absolute terms, but because the conversion bottleneck prevents them from exerting proportionate downstream influence. In this sense, COX and LOX bottlenecks are one of the places where chronic inflammation reveals itself as failed sequencing. The body still has enzymes. It still has substrates. What it lacks is efficient pathway transition. Seen clearly, enzymatic bottlenecks in the COX and LOX pathways are one of the reasons resolution cannot be reduced to supplementation alone. More precursor helps only if the tissue can route that precursor into the right mediator classes at the right time. If competition remains too strong, if early-phase chemistry remains too dominant, if oxidative instability remains too high, or if immune and tissue phenotypes never shift into the later logic of cleanup and repair, then the bottleneck remains in place. The body continues speaking the language of initiation because its enzymes are still being used as tools of initiation. Resolution begins to recover only when substrate availability, tissue state, and phase transition align strongly enough that those same pathways can begin producing the chemistry of completion instead of repeating the chemistry of escalation. Chronic inflammatory states. Chronic inflammatory states are what the body looks like when initiation remains easier than completion for long enough that the tissue begins to organize itself around unresolved defense. This does not mean the body is inflamed every moment at maximal intensity. More often, it means the tissue never fully returns to baseline. It remains slightly recruited, slightly permeable, slightly oxidatively stressed, slightly painful, slightly immunologically alert, and slightly structurally unfinished, and those partial deviations accumulate into a persistent biological climate. The key feature is not simply duration, is failure of closure. A chronic inflammatory state is a tissue condition in which the early and middle phases of inflammation keep reappearing or remain partially active because the resolution phase never gains enough control to complete cleanup, restore barriers, normalize signaling, and remove the evidence of danger that continues to justify further inflammatory behavior. This is why chronic inflammatory states are better understood as resolution-deficient environments than as mere excesses of inflammatory force. The body in these states still has access to arachidonic acid-derived eicosanoids, cytokine networks, vascular recruitment signals, neutrophil infiltration, nociceptive amplification, and stress-responsive immune activation. In that sense, the machinery of escalation is often intact. What is missing is the coordinated handoff into erythrocytosis, debris clearance, tissue protection, barrier restoration, and stable return to order. Apoptotic cells accumulate or are cleared too slowly. Oxidized membrane fragments remain in the extracellular environment. Endothelial and epithelial surfaces remain too open. Macrophages remain insufficiently effective as finishers. The inflammatory field, therefore, never becomes convincingly safe enough for the system to stand down. The body continues acting as though something is still wrong because at the tissue level, unresolved material and unresolved signals are still present. These states can be sustained by many sources at once. Barrier dysfunction in the gut can keep feeding immune-provoking material into circulation and local tissue. Mitochondrial stress can keep generating redox signals that mimic ongoing danger. Adipose dysfunction can provide constant low-grade cytokine and lipid signaling pressure. Mechanical overload can keep re-injuring tissue before repair completes. Oxidative instability can keep damaging membranes and producing secondary inflammatory byproducts. Infection, biofilm burden, environmental irritants, poor perfusion, sleep disruption, and metabolic dysregulation can all reinforce the same pattern. What unites them is not their origin but their effect. They keep the tissue from receiving a clean enough environment to finish the inflammatory sequence. The result is repetition. The body restarts defense because the old defense never fully ended. This is why chronic inflammatory states are so often multi-systemic in experience even when they begin locally. A gut barrier problem does not remain only a gut problem if immune activation, oxidative stress, and nutrient handling are altered systemically. Persistent vascular irritation does not remain only a vessel problem if endothelial dysfunction changes tissue perfusion, immune traffic, and signaling access across organs. Chronic joint inflammation does not remain only a local pain issue if nociceptive amplification affects sleep, movement, stress response, and systemic energy allocation. Neural inflammatory tone does not remain only a brain problem if autonomic signaling, immune surveillance, and barrier control begin shifting with it. The body is an integrated membrane and signal system, so unresolved inflammation in one domain often propagates cost into others. Chronic inflammatory states therefore feel diffuse because they are diffuse. The same unresolved logic is being expressed through multiple tissues at once. They also create a false appearance of adaptation. A person may look functional while carrying a body that is metabolically expensive, immunologically noisy, and structurally defensive. Symptoms become normalized. Mild pain becomes background. Digestive instability becomes routine. Brain fog becomes expected. Recovery slows and is interpreted as aging, stress, or overwork. But underneath that apparent adaptation, the tissue remains caught in partial emergency logic. The body is spending energy on surveillance and defense that should have been retired. Is rebuilding too slowly because cleanup is incomplete. Is responding too strongly to minor inputs because thresholds have shifted downward in a persistently unresolved environment. Chronic inflammatory states, therefore, do not always look dramatic. Often they look like a person slowly living inside the cost of not quite recovering. This is where SPM biology becomes especially relevant. Chronic inflammatory states often reflect inadequate pro-resolving pressure relative to the amount of inflammatory initiation the tissue is experiencing. Omega-3 derived substrate may be too sparse, too poorly incorporated, too weakly converted, or simply outcompete inside a site still dominated by arachidonic acid-heavy signaling. The result is a tissue that remains fluent in escalation and relatively weak in closure. It knows how to call for help. It does not know how to convincingly declare the event complete. That is why these states persist. The stop signals are too weak, too late, or too easily overridden by repeated retriggering. Without stronger resolution biology, the tissue keeps cycling through incomplete repair. Seen clearly, chronic inflammatory states are not just prolonged versions of acute inflammation. They are a different tissue reality. Acute inflammation is directional. It starts, amplifies, and is meant to end. Chronic inflammation is circular. It reopens itself because too much inflammatory residue, barrier failure, membrane instability, and unresolved signaling remain in place between episodes. The tissue never becomes clean enough, sealed enough, stable enough, or biochemically quiet enough to stop looking like a problem. That is why the solution cannot be framed only as reduction of inflammatory output. The deeper task is to restore the body's ability to complete inflammation as a program. Until that happens, the chronic state remains what it truly is. Not simply too much inflammation, but inflammation that never got all the way home. Why the body gets stuck? The body gets stuck when it can still initiate inflammation, but can no longer carry that inflammation all the way through to completion with enough consistency to restore tissue order. That is the central pattern. Is not usually a failure of detection. Is not usually a failure of force. In many chronic conditions, detection is strong and force is abundant. The body sees disruption, releases substrate for membranes, generates eicosanoids and cytokines, recruits immune cells, alters vascular tone, increases permeability, and amplifies pain. The early program still works. What fails is the transition. The site does not become convincingly safe enough, clean enough, sealed enough, or structurally stable enough for the inflammatory program to stand down. The result is a tissue environment that keeps re-signaling danger even after the original insult should have moved into closure. The body is not choosing chronic inflammation in the abstract. It is remaining inside a loop because the biological evidence required for exit never becomes strong enough. One major reason for this is persistent debris. Inflammation creates waste. Neutrophils die. Damaged cells fragment. Oxidized lipids accumulate. Membrane remnants, extracellular matrix fragments, and degraded proteins remain in tissue. If macrophage cleanup and erythrocytosis do not remove these efficiently, the site continues to display the remains of active damage. That matters because the immune system responds not only to the original trigger, but to what remains afterward. Uncleared apoptotic cells can become secondary necrotic material. Oxidized lipid fragments can continue acting as danger-associated signals. Structural debris keeps the local environment chemically unfinished. The body gets stuck because the site keeps looking like the work is not done, and in a real sense it is not done. Cleanup failure becomes reinitiation fuel. Barrier failure is another major reason tissues get stuck. A barrier that does not recover keeps letting in the kinds of signals that sustain inflammatory interpretation. In the gut, this may mean microbial products, endotoxin, incompletely excluded food-derived material, or other luminal stimuli continue reaching immune surfaces. In vascular tissues, persistent endothelial dysfunction can keep permeability elevated and tissue exposure abnormal. At the cellular level, damaged membranes can continue releasing distress chemistry that tells neighboring cells the local environment is unstable. The inflammatory sequence can only end if the tissue stops receiving fresh evidence that something is still wrong. When boundaries remain open, the body keeps treating the site as active because new provocation keeps entering faster than the old provocation is being resolved. The body also gets stuck when the substrate balance remains too heavily weighted toward initiation and too weakly weighted toward completion. If membranes are rich in arachidonic acid-derived inflammatory potential but relatively poor in EPA and DHA-derived resolution substrate, then the tissue has more material for escalation than for closure. That does not mean omega-6 is illegitimate. It means the later phase chemistry is underpowered relative to the force of the earlier phases. Even when omega-3 is present, downstream conversion into specialized pro-resolving mediators may remain weak because of enzymatic bottlenecks, oxidative instability, repeated retriggering, or poor phase transition. The body gets stuck because its biochemical language is skewed toward go signals and underdeveloped in stop signals. Energy is another hidden reason. The body can often afford to start inflammation before it can afford to finish it. Initiation is fast and can ride on stress signaling, acute substrate release, and immediate immune mobilization. Resolution is labor. Efferocytosis costs energy. Membrane repair costs energy. Restoring barriers costs energy. Re-establishing gradients, rebuilding structure, and shifting immune cell phenotypes all cost energy. A tissue under mitochondrial strain can therefore remain capable of inflammatory activation while becoming poor at inflammatory completion. The body gets stuck because it has enough power to enter defense and not enough organized metabolic capacity to pay for cleanup and reconstruction afterward. There is also a signaling memory problem. Once a tissue has been through repeated inflammatory cycles, its membranes, receptors, thresholds, and local immune behavior begin to adapt to that environment. The site becomes easier to trigger. Receptors become more likely to amplify. Nociceptive systems remain sensitized. Endothelial and epithelial behavior normalize more slowly. Macrophages may become less efficient finishers. In other words, the tissue learns chronicity at the structural level. It begins to interpret ordinary inputs through a defensive architecture. The body gets stuck because the tissue no longer requires a dramatic threat to behave as though threat is present. The threshold for returning to emergency mode has fallen, while the threshold for returning to true baseline has risen. This is why the body often appears trapped in a half-healed condition. Symptoms fluctuate, but the underlying state remains unresolved. A person may feel a little better for a time, then flare again from a minor trigger. That pattern is not random. It reflects a tissue that never fully exited its previous inflammatory event. Enough improvement occurred to reduce intensity, but not enough cleanup, barrier restoration, membrane stabilization, and pro-resolving signaling occurred to create durable closure. The site remained vulnerable to reopening because it never stopped being biologically unfinished. Seen clearly, the body gets stuck because inflammation is a program that requires a real end state, and that end state depends on multiple things going right at once. Debris has to be removed. Neutrophil recruitment has to stop. Macrophages have to finish well. Barriers have to reclose. Membranes have to stabilize. Omega-3 derived resolution signals have to become strong enough to matter. Energy has to be available for repair. If too many of those conditions fail at once, the body does not return to baseline. It stays in a repeating loop of partial activation, partial cleanup, and rapid reinitiation. That is what stuck really means. The system has not lost its ability to respond. It has lost its ability to convincingly declare the response complete.